chemical nomenclature. The word nomenclature is just a fancy word for naming. Okay, so chemical naming, and in fact involves one of two things. You're either given a name of a compound and you're going to write the chemical formula for it, or the reverse, you're given a chemical formula and you need to know the name of the compound. There are 7 subcategories here of nomenclature, but if you look at them with a discerning eye, you could probably break them into 3 broad subcategories. The first would be ionic compounds, and you'll notice there's several types. There's binary ionic compounds type 1. We'll see what that means in just a moment. Binary ionic compounds type 2. Ionic compounds that have complex ions in them, and hydrated ionic compounds. So 1 to 4 are all dealing with ionic compounds. Number 5 will deal with covalent compounds, binary covalent compounds, and 6 and 7 will deal with acids. There's 2 different kinds of acids, binary acids and oxyacids. Okay? Let's jump in. Some basic definitions. An ionic compound, the most important part of this definition, or at least the most useful part, is to remember that it involves a metal bonded to a non-metal. When you see a metal element bonded to a non-metal element, you know you're looking at an ionic compound. Now that's only useful if you remember on your periodic table that the metals are over here and the non-metals are over there. Okay? So if you remember that, then when you hear the name sodium chloride, table salt, sodium chloride, you know that sodium is over on the left, it's a metal, and chloride is over here on the right, it's a non-metal. So sodium chloride is an ionic compound. A little bit more depth, we know that metals tend to become cations. They tend to lose electrons and become positively charged. Non-metals become anions. They gain electrons from the metal and they become negatively charged. Well, in the homophobic world of chemistry, we're going to get an attraction there. Opposites attract. So the positively charged cation will see the negatively charged anion, and those 2 things will attract each other. You'll have an ionic bond, an ionic compound. Okay? You can think of ionic bonding, if you prefer, as sort of the capitalist type of bonding. There is a giving and a taking, a selling and a buying of electrons. Contrast that with the socialist, communist way of looking at things. Instead of giving, taking, buying, we'll share. We'll share. So covalent, the prefix co, implies together, sharing, and valent implies valence electrons. So rather than me giving away an electron and becoming positive, and you taking an electron and becoming negative, and then there be an attraction, opposites attract, instead we'll share electrons. Okay? If we're sharing electrons, then we stay together because, like a husband and wife who don't like each other, they might have kids, and so they stay together for the kids, right? So one atom is attracted to the electrons, the other atom is attracted to those same electrons, and so the 2 atoms have to stay together. You have a covalent bond. They're sharing valence electrons. The word binary means 2, right? Binary means 2. So we're only going to look at the beginning here at compounds that have 2 elements. So that could be something like water, H2O. That's a binary compound because it's made of hydrogen and oxygen, just 2 elements, right? On the other hand, potassium nitrate, you might remember from grade 9 science, is not a binary compound because it has 3 elements. elements: potassium, nitrogen, and oxygen. Okay? So we're going to start with just binary compounds, and then we'll get to the other ones like potassium nitrate when we look at complex ions. Anything there unclear? We're good? All right. The first type of ionic compound is a type 1 compound. What the hell does that mean, type 1? Here you want to look at page 6 of your data booklet. Okay? It's going to be very important. When you look at page 6 on the data booklet, you'll notice that there are ions that have just one possible charge. And on a periodic table, pardon my bad artwork, but on a periodic table, that could be column 1 and column 2, groups 1 and group 2. If you're in group 1, your charge is always 1 positive. If you're in group 2, your charge is always 2 positive. Skipping the transition metals in the middle, if you go all the way over to group 13, the one that has aluminum in it, your charge is always 3 positive. Skip the carbon family and go to the family with nitrogen in it, your charge is always 3 minus. Oxygen's family is always 2 minus. The halogen family is always 1 minus. There's a whole bunch of ions where there's only 1 charge. When you look in the transition metals, you'll notice there are 2 ions given on page 6 of the data booklet, zinc and silver, Zn and Ag, that are also type 1 cations. They have 1 charge only. Okay? So zinc is always 2 positive, silver is always 1 positive. So if you are a type 1 cation, you will only have 1 possible charge. On page 6 in the middle, transition metals, if you look, you'll see there's a whole bunch of ions, cations, that have 2 possible charges. Iron can be 2 plus or it can be 3 plus. Copper can be 2 plus or 1 plus. So there's a whole bunch of ions that have more than 1 charge. They're going to be called type 2 cations. Here are some examples of type 1 cations, and notice they're found, some of them you should just be able to predict the charge. Sodium is in group 1, alkali metal. It had to be 1 positive. Calcium is in group 2, alkaline earth family. It had to be 2 positive. Aluminum, if you look on the periodic table, had to be 3 positive. So those 3 right there, you could have predicted the charge by looking at where they are on a periodic table. Zinc, though, you have to just memorize. Zinc and silver, you just have to memorize. Zinc is 2 positive, silver is 1 positive. Notice something else very important here. Okay? This is very subtle, but it's important. If I just said Na, what's its name? Just Na, you'd say sodium. Na positive, the cation, is also called sodium. The cation's name is the same as the name of the element. Okay? That's sometimes a little bit confusing, but usually the context makes it clear whether you mean sodium the element or sodium the cation. Okay? The context will almost always make that clear. When you look at the anions, okay, down here we've got some anions, you'll notice there's a difference in the way they're named. Oxygen becomes oxide, nitrogen becomes nitride, fluorine, fluoride, bromine, bromide, and if you go down all of the anions on your periodic table, you can drop the ending and just add IDE. Some of them are a little bit, they're not always intuitive. Iodine becomes iodide, sulfur becomes sulfide, phosphorus, this one tricks people up a bit. Phosphorus is not phosphoride, it's just phosphide. Okay, so they're usually clear, but there's 1 or 2 like phosphorus that are a bit tricky in how to name them. So an anion drops the ending to its element name and changes it to IDE. Okay? Any questions about that? Then let's put them together and make some compounds. Okay? One of the most important things to understand is simply based on grade 8 integers math, grade 7 integers math. When you put the cation and the anion together to make a compound, the charges have to cancel out. Okay? Charges must cancel out. Sometimes they cancel out automatically. For example, Na positive, sodium, and Cl minus, chloride, plus 1 and minus 1 cancels out, so the formula of table salt is NaCl. Lithium oxide, though, does not work quite so simple. Lithium is plus 1, oxide is 2 minus, they don't cancel out. Because they don't cancel out, we have to do this. If lithium is plus 1, instead of just 1 lithium ion, we're going to need 2 lithium ions. Oops, that didn't quite work. 2 lithium ions are going to be needed. Li plus and another Li plus. Now I've got not 1 positive, but 2 positives. That will now cancel with the 2 minus from the oxygen. So the compound lithium oxide is given a formula Li2O. And the 2 there is called a subscript. It's written below the main line of your writing. What does that tell us? What does the 2 mean in the formula Li2O? There's 2 what? There's 2 atoms of lithium, and when you don't see a subscript, there's Li2O, there's no subscript beside O. What does that mean? There's 1 atom of oxygen. So Li2O, 2 atoms of lithium bonded to 1 atom of oxygen. Take a look at aluminum bromide. Does this make sense? Aluminum's charge is 3 positive. Bromide's charge to halogen is 1 minus. 3 positives and 1 minus. How could I make that cancel out? Well, I'll keep 1 aluminum, 3 positive, and I'll need 3 of the Br minuses, won't I? Right? So not just 1 bromide, but 3 bromides. Now I've got 3 positives and 3 negatives. So now the formula will be AlBr3. And this 3 down here, the subscript, only applies to bromine. It doesn't apply to aluminum. So there's 1 aluminum in that formula and 3 bromines. Okay? Is that making sense? Okay. Here's the toughest one of them all. And I'm not joking about that. Okay? If you get what we're doing so far, great. This is now the toughest example. When something has a charge of 2 positive and it's bonded to something with a charge of 3 negative, how can I make the charges cancel out? Well, what's the lowest common multiple of 2 and 3? 6. So how many 2's do I need to get 6?
3.
So I'll need 3 zincs. 2 plus, 2 plus, 2 plus. I've now got 6 positives. How many 3's go into 6? 2 of them. So I'll need 2 and 3 minuses. So 3 minus and 3 minus is 6 minus. So now I've got 6 positives and 6 negatives. So the formula is Zn3N2. And that's as tough as it gets. Okay? Let's see if we get this. You've got about 1 minute. I want you to try 2 of these on each side. Take zinc chloride, write the name down. Beside the name, put the formula for the 2 ions, and then put them together to make the formula of the compound. We'll do one example of this. What's the charge on zinc?
2.
So I'll write Zn 2 plus. What's the charge on chloride?
That's 1.
It's a halogen, so Cl minus. Notice something? If I have to keep looking in my data booklet for the charges, this is going to take a long time, isn't it? Right? Now, I've been doing this for 20 years, and it's pretty easy, but very quickly, if you take a little bit of time and effort, this is not hard to memorize, and then it's very fast. So Zn2 plus and Cl minus, Riley, what will be the formula of the compound? Say again? You know what? I'm glad you said that. Cl2Zn? No. Okay, I didn't say this, but there's an important point that I should have mentioned. Did you notice in every example we did that positive cation was first and the negative anion was second? The metal before the non-metal? Even in the name, zinc chloride, the metal comes first. So instead of Cl2Zn, you should have said ZnCl2. Does that sound familiar to you? Zinc chloride?
Yeah.
Grade 9 science, we synthesized zinc chloride. All right.